y equals x squared sine x. Let's have a little go at this one then. Now the curve y equals x squared is a u-shaped curve, so let's draw that in. So it's going to just come down and be a u-shaped curve. It's going to go through the origin, isn't it? And it's going to be the same the other side. So I'll try and draw the same u-shaped curve the other side. Okay, so that's y equals x squared. The sine x curve then? Well, it's going to reach a maximum of 1 and minus 1. So here's 1. Oh, I won't do that. I'll just mark off 1 and minus 1. So here's 1. Here's minus 1. Let's put in pi here and 2 pi here. And let's just mark off our sine curve then. Pi over 2, it's up here, isn't it? And then it goes to 0 at sine pi. Minus 1 and then 0. And here's the actual sine curve, which I'll just dot in here. There, like so. And then the same the other side. So you've got minus pi, minus 2 pi. So it's 0 here, 0 here. And it goes down to minus 1, doesn't it? Just here. And then back up. And then it goes up to 1. At minus 3 pi over 2. And then back down to 0. So there's the curve. Okay, so now we need to draw this curve here. Well, 1 times the value is the value itself, so we can mark that off there, because we're doing the product of these two functions. 0 times something is 0. Minus 1, so I'm going to need to draw the reflection, aren't I, of the curve. So let's do that then, of the curve y equals x squared. So let's draw that in. Like so. And the same the other side. And try and draw it the same. Okay, so now we're ready to mark off the minus 1 point now. Minus 1 times the value of the x squared is the value itself. There. 0 is there. So what's going to happen is this is going to increase probably more rapidly than this. So the minimum is going to occur just after. We could find the minimum by differentiating. So let's do that, shall we? So it's u x squared times the v dx, which is cosine x, plus v, which is sine x, times du dx, which is 2x. Let that equal 0. And then we've got taken x outside of the bracket, and we've got cos x times an x plus 2 sine x. Okay, so that's what we've got. So it's doesn't throw much more illumination on the problem other than to say we've got a turning point at when x is 0. So okay, let's have a look at this then. So we go back up to 0 here, and then we're just going to carry on. So it looks like we come down here, we come down to a minimum, we go back up through 0, we go up to a maximum, come back down. Then we go down to 0, and then at minus pi over 2, we're going to be here, minus 1. When it's 1, we're going to be up here, aren't we? So it looks like we've got the same. So here we go to this value. So we come around here, and then we go to this value. Come round and go up to this value. Come round and go down to the next value. Okay, so that's what we've got then in terms of the curve. So I'm going to try and draw it in with a solid line now. I'm fairly okay with it. Our minimum, and then through here, and then up through here and round. Okay, let's have a look at the graph. This should have looked the same both sides but opposite. So this should be up a bit higher, shouldn't it? I think so. Should be up a little bit higher to make it look the same as on the other side. So let's have a look at our plotter then. We want to do x squared sine x. Let's have a look at that. X power squared times the sine x between, let's do minus 6 to 6, roughly 2 pi to 2 pi. And yeah, we get that classic little look there. yeah, there's a turning point at the origin here. So it came up to a maximum there, and then it turned here, didn't it? The maximum was at just over 2. Pi over 2 is 1.6, so the maximum is just before this value here.